Hi, welcome to Sakambuta Online Academy. Before we enter our today's discussion, I would like us to just, I would like to make mention a few things. Number one, please, these videos that I'm doing are meant to, help students that are struggling with the certain concepts to be able to, watch them and also be able to learn two things from there. Number two, please do well to follow us on our Facebook page, and also you can actually find us on YouTube. Simply type Sakambuta Online Academy. You'll be able to get hold of the channel, and please do well to subscribe to that YouTube channel so that every time a new video is uploaded, you'll be able to get a notification. And that's the beauty of subscribing to a channel. And number three, please don't just view the video or just watch the video. Please do well to at least drop a like, share, and even comment so that we can make some progress in terms of where to improve. You'll never know whether the video is okay if people are not commenting. So the purpose of commenting and sharing and liking is to provide room for improvement. Otherwise, I really appreciate you all for the support that you always give me. And I pray that you continue to give me the same support so that we can take education to another level. Now, in today's discussion, I would want us to look at another lesson still under stereochemistry. And this time around, I want us to see how we can name stereochemical compounds. So I have two questions that I picked in one of the exam papers that I came across. So I decided that we discuss these questions so that we see how best we can answer them. So stereochemistry, the nomenclature of stereochemical compounds. Now, the question was, name the following compounds using Kern-Ingot-Prelog system for stereoisomers. So this was the first compound that were given, and the question is asking us to actually name this compound here. Now, remember that this is a stereochemical compound. So when you're naming stereochemical compounds, we don't just name them as we name organic compounds, but rather we should be able to take into account the RS configuration where it applies. So, remember in the video that I did mention that the RS configuration applies to a chiral center. So meaning that the first thing that you have to do or to look out for is a chiral center in that given compound. Once you find the chiral center there, and then you should be able to assign whether it is RS configuration, whether it is R configuration or S configuration. From there now, that's when you can name the compound. So I want us to look at that, to do that in this question. So if you look at the compound that you have here, you discover that what you have is simply one chiral center, which is this one here. Why are we saying this is a chiral center? Because we said a chiral center is that center. It's actually a carbon that has four different groups. So we have this group here, this group here, and the whole lot of this. So the four groups are attached to this carbon. So this is a chiral center. This can't be chiral carbon because this has got hydrogens, three of them, and these hydrogens are the same. So this is not a chiral center. This is a chiral center or a chiral carbon. So this one also is an achiral carbon. So we cannot apply the RS configuration to an achiral carbon. So the RS actually applies only to a chiral center. So in this case, the chiral center is this one here. So what are we going to do? What we're going to do is first to assign the RS configuration to this chiral center. Once you've done that, that's when you can now go ahead and name this compound here. So again, remember the rules that we did. We say that the priorities are given based on which atom has got the highest atomic number. So in this case, around this chiral carbon here, we've got a bromine, hydrogen, methyl group, and this ethyl group here. So what we're going to do is, you see that we have got bromine connected to this carbon, we've got hydrogen connected to this carbon, and we have a carbon here which is connected to this chiral carbon, and we have another carbon here which is connected to this chiral carbon. So we're going to consider that. So among the four, you discover that bromine has got the highest atomic number. If you check on the periodic table, you'll be able to find that. So because bromine has got the highest atomic number, we are going to number it like this. So we'll give it 1. Okay, that will be the first priority, first priority given to this. So after this, we have got a carbon and another carbon here. So carbon and carbon, it becomes a tie. So we can't pass judgment on which one should be given to. So we need to look at the other elements that are connected to these two carbons. So here we've got a carbon which is connected. Here we've got we have got a hydrogen which is connected. So if you look at the atomic numbers for carbon as well as hydrogen, you discover that carbon has got a higher atomic number than a hydrogen. So because of that, this whole group here will be number 2. Okay, and therefore this will be number 3, and hydrogen is always number 4 if it's there. So now, according to the rules, we said we're going to cancel out 4, or we cross out 4, and then we're going to trace an arc now. And this arc should be should be done in the manner that it should start from 1, go to 2, from 2 to 3, like that. So if you check properly, the direction that you're taking is a clockwise direction. So it's moving, the configuration is moving in the direction of the clock. So we say that if the configuration is moving in the direction of the clock, we say it is R configuration. But in this case, we need to look at the 4, the group that is on 4, number 4, the least group. Where is it? Is it pointing at you, or it is pointing away from you? Okay, now remember what I said, that if it is on a wedged bond, this is a wedged bond, and the group that we are considering here, which is on number 4, is hydrogen. So therefore, this is on a wedged bond. That's a least group. So because of that, instead of because this one is pointing, it is pointing at you, and it should always point away from you. So because of that, we are going to take the opposite of that configuration. So instead of having R, we are going to have S configuration on this carbon here. I hope that helps. So if this is pointing at you, you have to take the opposite of the configuration. So the original configuration would have been R, but because the least group, which is 4, is pointing at you, how do we know that it's pointing at you? It has to be on the wedged bond. So it's pointing at you. So take the opposite of that configuration, and that becomes R. So once you have assigned the RS configuration, you now come to what we are calling as now the naming system. So you now name this compound the same way you name organic compounds. So therefore, we are going to say this is number 1. Okay, remember that you take the shortest route, so to the substituent. So we have 1, 2, carbon 2, carbon 3 here, and then carbon 4. So meaning that the parent name of this is butane. Now, what do we have on carbon 2? On carbon 2, we have got a bromine. Now, before that, you're going to say, now therefore the name is going to be, you start with the configuration, which is S in this case. You do it like this, and then you put a hyphen. Then what do you have on carbon 2? On carbon 2, we have a bromine. So you're going to say 2-bromo. 2-bromo. Now, what is the name of the parent chain? The name of the parent chain is 1, 2, 3, 4. So it's butane. 2-bromo butane. So this is the name of this compound. So S is the configuration, the RS configuration. This 2 is telling you that on carbon 2 we have got a bromine. So 2-bromo butane. Now the butane is the parent name of this compound. The other question that came, which I thought we should look at, is this one here. Is this one here. Now, if you look at it properly here, this compound, you discover that you've got 2 chiral centers, this one here and also this one here. So you should be able to identify chiral centers. So we're going to assign the RS configuration to these 2 chiral centers. So let's begin with this one. Now, so chlorine, carbon, carbon, and hydrogen. So chlorine has the highest atomic number, so it will be given the first priority. Then number 2, we have now this carbon here and this carbon here, so it's a tie. Now let's look at what is connected to these carbons. Here we have a hydrogen, here you have a hydrogen, here you have a hydrogen, so 3 of them. Here you have a bromine, so bromine wins over hydrogen in terms of which one, in terms of the atomic number. So this is going to be number 2, and this is number 3, and this is number 4. So you cancel out number 4, you trace an arc from 1 to 2 to 3. So this is a clockwise direction. Now let's look at the least group, which is 4. Is it pointing at you or away from you? So you discover that this is pointing away from you. How do we know? Because it is on the dashed bond. So because of that, this is going to remain as the R configuration, like this. And then you come to this one also, you do the same. So bromine is going to have the first priority. I'm sure this is going to be the second, because if you look at what is connected to this is carbon and this is carbon. So this carbon is connected to a chlorine, this one is connected to a carbon. So chlorine has a higher atomic number than carbon, so therefore this is going to be number 2, and then this is going to be number 3, this, and this is number 4. So you cancel out 4, you trace an arc again from 1 to 2 to 3, and you are also moving where? In what direction is that? This is the clockwise direction. Now let's look at our 4. Is it pointing at you or away from you? This, it turns out that this group 4 here is pointing at you. How do we know? Because it is on the wedged bond. So because it should always point away from you, we're going to take the opposite configuration, which in this case is going to be S instead of R. So you have assigned the RS configuration. Now let's name the compound. So there are 2 routes. There's this route here from 1, 2, 3, 4, 5. And then you can also number it from 1, 2, 3, 4, 5. But you should always take a route which is near to the substituent. So in this case, this route here, 1, 2, 3, 4, 5, leads us or takes us to a substituent which is closer to this. So we're going to take this route. So we're going to number the carbons, number 1, number 2, number 3, number 4, number 5. It looks a bit messy, but don't worry. Just keep following. So this is number 1. So let's look at what do we have on number 2. On carbon number 2, what we have is a chlorine. What about on carbon 2, on carbon 3, rather, here? On carbon 3, what we have is a bromine. So what you're going to do now here, in this case, is that we're going to say this R here is on carbon 2. So we're going to say 2R, comma, and then here on carbon 3 we have got S configuration. So we're going to say 3S, you open bracket and close it like this, you put a hyphen. Now what do you have on carbon 2 again? We have chlorine. On carbon 3 you have bromine. So between chlorine and bromine, in terms of alphabetical order, which one comes first? It's bromine. So you're going to consider bromine. So you always have to follow alphabetical order. So on carbon 3 we have bromine. So we're going to say 3 bromo, 3 bromo, 3 bromo. Then chlorine is on carbon 2. You say 2 chloro, 2 chloro. Now, what is the name of the parent chain? It has got how many carbons? 1, 2, 3, 4, 5. So it becomes the pentane. So we're going to say pentane here. So this is the name of this compound here. I hope this helps. Please, this is Sagamte Mano, the CEO of Sagamte Online Academy. Please do well to subscribe and do well to share. Do well to like the video and also comment. That is enough to support your brother. Thank you so much and keep following. Thanks.